Hello guys, welcome. I am Shivraj. Today I am going to show you how to compute nonlinear optical properties using Gaussian software. I am using Gaussian software to build molecule. I had already built urea molecule. I am taking it as an example and it has good nonlinear optical properties. It possesses second harmonic generation as well. Okay, let us compute nonlinear optical properties for this molecule. Go to the calculate and choose your job type. I have chosen it for energy. Choose your methods. Chosen for ground state DFT under this B3LYP, and choose your basis set according to your molecular type. Chosen 631G. If you want checkpoint file to generate molecular orbitals, can choose and use polar keywords. Polar is equals to TCSHE, cubic. DCSHE direct current second harmonic generation. It gives first hyperpolarizability and second harmonic generation coefficients, and also type CPHF. It is coupled perturbed RT fork is equals to RD frequency dependent computations, and we are not using any solvation here since we are computing in the gaseous phase. In the additional print, you may have additional input. You may have to give required frequency since it is frequency dependent computations. There is a relation to calculate, and this is in atomic unit. 45.56 divided by wavelength, it should be in the nanometer. I am using 1064 wavelength, and it gives the value 0.04282. remember, it should be in atomic unit, and make sure your keywords are correct, otherwise you may encounter with the error while running a job. That's it. Submit, save it. Submit the following file to Gaussian. I am not going to submit because I already computed. Since it takes a really long time, I don't want you to wait, so I will open the output file. Here is the output file, and you will see normal termination of Gaussian 09, and it has ended with the beautiful quotation. Come to the top where you will see, yes, nonlinear optical properties starts from here. You will see the electric dipole moment. You will see the components here, XYZ, and the dipole moment in atomic units, dBase and SI unit, and dipole polarizability. This is alpha static, it doesn't depend on frequency. You will see the dispersion coefficients are 0, 0 here, and here it is isotropic and anisotropic polarizabilities, and you have a formula to calculate these isotropic and anisotropic polarizabilities using these components. And this is frequency dependent polarizability minus omega, it is dispersion coefficient says. And next, first dipole hyperpolarizability, that is beta, and you will see it is also again a static one, static beta. You will see the parallel and perpendicular components, and you will see the beta vectors, beta x, beta y, and beta z. You will see the tensor components, and beta minus omega, omega 0. This is the frequency mixing process, that is electro-optic Pokel's effect, we call it as, at 1064 nanometer wavelength. And you will see 18 beta tensor components. Beta, this is second harmonic generation first hyperpolarizability. Yes, it has 18 components again, and you can calculate total beta using the relation you will see in many literature. And next, second dipole hyperpolarizability, that is gamma, and it is also called third order process. Yes, it is also static one, and this parallel component will give the average gamma value. And next, this is due to optical carrier effect, that is DC carrier effect, direct current carrier effect, since the dispersion coefficient minus W comma W, and you will see many components. And this is due to electric field induced second harmonic generation, and it is not a third harmonic generation. It is, you will see 2 omega, it says second harmonic generation, where two frequencies were mixed, two equal frequencies were mixed to give a resultant frequency 2 omega, and it is electric field induced second harmonic generation. And you will see many components, and you can calculate the average gamma using the relation. And from, as far my knowledge is concerned, you cannot calculate third harmonic generation using this Gaussian software. You may have to choose some other softwares like GameS or Dalton or something. And if you don't want to calculate polarizability and hyperpolarizability for frequency dependent calculations, you may use just polar keyword in the root section. You will see I had only used polar keyword for this. You need not have to specify any frequency. This is for static one. You will see polar is equals to, you will see the 6 components here, and hyperpolarizability 10 components here. Using these components, you may have to calculate the total hyperpolarizability. Okay, thank you for watching. If you are having any queries regarding this, just comment. Thank you very much. See you.